I work in the Edward S. Rogers Senior Department of Electrical and Computer Engineering, and I've been here in the department for about a year, almost a year and a half, and so now I'm finally confident in saying the name without reading it. So that's me. So I just thought I'd talk a bit, one of the questions I get a lot at recruitment events is what is electrical engineering, what is computer engineering, and what's the difference between computer engineering and computer science. So I thought it might be helpful to talk about that a bit. So of course, pretty much everything that we use these days has an electrical component, whether it's your cell phone or the lights here, computers, everything around us uses something that an electrical or computer engineer had something to do with. So electrical engineers apply their engineering skills to the design, manufacturing, the applications, installation, and operation of electrical products and systems. So everything from the electricity grid to, like I said, the chips in your phone. Some of the fields within electrical engineering, and I'll talk about our research groups in a bit, are communications, systems control, biomedical engineering, electromagnetics, photonics, electronics, and energy systems, like I mentioned. Computer engineers, on the other hand, design, develop, and test software, computer networks, and protocols. So every automated device, every computer, every wearable technology has software and or hardware that an engineer helped to create. So whether it's what's in your phone or what's in an airplane flying over us, robotics, anything like that, a computer engineer has likely had a hand in. So then we come to the big question is, what's the difference between computer science and computer engineering? And I get this all the time, and I ask this all the time, and every person tells me a different thing. So it's kind of a fuzzy area. In fact, some universities have combined electrical engineering and computer science departments. So there's not like a hard line where you stop walking in computer science and start walking into computer engineering. And it's not just the hardware and the software, which I think is a bit of a misnomer. That's computer scientists just work on software and computer engineers just work on hardware. Even the design of hardware takes software to do. So I would say, and don't quote me on this, which you will because it's being filmed, that computer science is a little more theoretical. One of the examples that I like to use is we've heard a lot about machine learning and deep learning in particular. And Jeff Hinton here at the University of Toronto's Computer Science Department had a lot to do with that. But that theory he had worked on and was talking about in the early 90s. So it was not until sort of computer engineers helped to help to create sensors that would collect the data, because you need reams of data for this to work. To have the GPUs that are required to process the algorithms, that theory sort of turned into an actual tangible thing that we're using all the time and more so. So yeah, I would say a little more theory in computer science, but computer engineering doesn't mean that you're not doing software. So if you can help me to debunk that, that would be helpful. So ECE at U of T, so we've got a big department. We have about 100 professors, including emeritus. So active professors, I think we have about 80. There are 8 research groups, which I'll talk about a little bit more, and you'll see how there's sort of an overlap not only with computer science, but with other engineering departments. So these numbers were as of last year. So we have about 1,500 undergrads, 650 graduate students. We're the top ranked school in Canada for electrical and computer engineering, among the best in the world. Lots of really exciting innovations coming out of the department. So inventions, startups, patent applications, and that's everyone from our undergrads to our professors are doing some exciting stuff there. So our 8 research groups are as follows. So the first 4 are biomedical engineering, and I think Luke will talk about the IBBME program. So there's a lot of overlap of our profs there. So from my perspective, these are electrical engineers that are using their electrical engineering to help solve medical challenges. So whether it's actually like implanting things into humans or mice in some of their cases to help prevent or identify epilepsy or medical imaging, so MRIs and all that. Our computer engineers, so I'll just speak briefly, we're world-renowned. We've got a really great collective of people working on FPGAs, field programmable gate arrays. So those are reprogrammable chips. And some of the best people in the world are here in ECE working on that. And in fact, Intel has set up shop so Intel purchased Altera, and Altera purchased a startup from a couple of our profs, and they've set up shop just by the ROM. And so we have a lot of our students doing their doing co-op there or working there after they graduate. So communications group, they work on signal processing, information communication theory. So that's basically how messages or anything transfers from what you type in your keyboard to all the way around the world. Electromagnetics group, so they're working on stuff like antennas. So, shooting these antennas into space so that we can have shore-to-shore communication or ship-to-shore. There's a lot of defense applications for people working in our electromagnetics group. Electronics, so they're working on solid-state devices, so no more vacuum tubes. They're creating integrated circuits or chips for all sorts of use. Energy systems group works on power systems, DC transmission, anything to do with the generation and distribution of power. And one of the challenges for them is renewables. We're hearing a lot about renewables, so there's a whole slew of challenges that weren't seen in our traditional energy systems. So they're working on that. Photonics, they work on, well, as you know, photonics light, so anything to do with fiber optics, generating, detecting, moving, manipulating the transmission of light. Systems control, so they work on everything from robotics to other dynamical systems, like, I'm trying to think of some. Oh, so like your thermostat changes in your house when it's cold. There's a control systems research on the end of that. So yeah, our undergraduate students study, it's kind of a unique program. The first 2 years are common, and it's not until the third year that they start to decide which areas of study they want to focus on. So this is from a recruitment presentation, so I'll just skip that. So just some stuff that's been going on in the department lately. So I don't know if any of you are familiar with Sandro Young. He was U of T's top student, so he had the highest grades of all graduating U of T students across all 3 campuses this spring. And so he won the Governor General's Medal and a whole slew of awards. He's also active in the Spark Student Club, so just the diversity of our students. He wasn't studying the whole time. And he's off at Google now. Last I heard, he was trying to get into their machine learning group, but I'm not sure where he landed. So like most engineering programs, we have a 4th-year capstone project. So I just thought, I can't really see them, but I talked about some of the projects from last year. So the one in the middle down here, this was using your credit card instead of a key card to unlock a door. So at a hotel, if you book a hotel on your credit card, instead of going to the front desk and having to get your own card, you could just use your credit card to lock and unlock the door. What else? Above that was a hand stabilizer for patients with Parkinson's. So that was a group of engineers a group of engineering students that worked on that. That was really cool. We've got a few apps. What else do we have here? That's Professor Hans Kunoff with his group, and that was a Braille machine, I guess. So for people that were blind, they would hold their visually impaired person would hold their hand over it, and the I guess buttons would come up in the shape of the Braille, so they could read instantaneously instead of having to purchase a book. So that was really cool. Every year we do a bunch of projects with the CNIB. What else do we have? So a bit about PY. So we have students heading all over the place. A lot of our alumni and a lot of our PY paid internship students are in California. A lot go to Silicon Valley. Yeah, so that was last year the top salary earned by an ECE student on PY. So I guess we all wish we were an ECE student on PY. But that was sort of like an anomaly. 55. So just some of the places that people go. So obviously Google, Facebook, Apple. But we have people in small startups, either on their PY or working, to big companies, to Hydro, where else? Uber, of course. But keep in mind that every company and every organization uses computers and uses electricity, right? So when I have parents asking me where is my kid going to work, it could be anywhere. And so just a bit about our alumni. So these are some of our notable alumni and where they're working. So I tried to include some startups. So everyone knows Nanoleaf, the world's most efficient light bulb. Wattpad, which is like YouTube for books. Jeff Skoll was one of the early employees at eBay. I'm not sure if you're familiar with the crest in the top right corner, but that's the crest of the Governor General. So Julie Payette was recently named the Governor General. So when parents ask me where's my kid going to work, I could say, well, they could be the Queen's representative in Canada, but they'll probably work at Google. And I brought some of our annual magazine, Annam. So it's a huge document. So at the front, there's a few stories, some facts and figures, and then if you flip it over, it's every active research project in our department. And you can see there's a lot. So if you ever want to flip through there to see what some of the people are doing in ECE, it's all yours. And if you have any questions, let me know. Thank you very much.